Right, let's write down the concept involved in solving this simple exponential equation. So concept involved. Right, is to express. Right, to express both sides of the equations. Both sides of the equation with the same base. To express both sides of the equation with the same base. Okay, 1, 2, then you equate the power or the index or the exponent. Equate the index, right, or the power or the exponent. They all mean the same thing. Okay, right, so let's look at A. Right, so 256, you can actually use a calculator to help you. 4 to the power of 1, no. 4 to the power of 2, no. 4 to the power of 3, no. 4 to the power of 4, 256. So 256 is 4 to the power of 4, right? So we have successfully expressed both sides to the same base, that's base 4. Then we equate the exponent. This one is called the exponent if you have forgotten. So from there, x will be 4 divided by 2 equals to 2. Okay, pretty simple. Right, part B. Right, so we can write 8 as 2 to the power of 3. That's why you don't really need the calculator to help you. And then change the bracket to times. Right, change the bracket to times. So it will be times 2 to the power of negative x. And here, all right, observe that you have the same base and you are getting a times in the middle. So the concepts we are applying here is if you have same base and if it's times, then you just add the power. So you would have 2 to the power of x. On the left hand side, then on the right hand side will be 3 plus bracket negative x. Okay, so we have successfully also expressed it as base 2 on both sides of the equation. Now we can equate the power. X is equals to 3. Right, so positive times negative is negative. Right, so we can bring the x together on the left hand side. And then you can divide by 2. So x is 3 over 2, which is 1.5. Alright, relatively easy. Right, so let's summarize. So the three concepts involved here is, first of all, to express both sides of the equation with the same base. And then the second concept involved is that you equate the power. And the third concept is that if there's any other things that you need to manipulate the equations, then you may have to apply the relevant rules of indices you have learned. On the concepts that we have learned. Step 1 is we will try to express a number given in the equation with the same base on both sides of the equation, and then we will solve it by comparing the exponents. Right, so if you were to use a calculator to help you, 5 to the power of 3 will give you 125. So therefore 6x will be equals to 3. So x will be 3 divided by 6 gives you half. So this is relatively easy. Right, so let's look at part B. Right, so 49, we can write 49 is 7 to the power of 2. Then the next very important step is to convert your brackets to times. Right, remember to convert the brackets to times, because if you convert the brackets to times, then that will give you an idea that you have to use this rule that we have learned earlier on. Right, so the base here, the bases here which are the same, it's the number 7, and then you have the operation which is times. So what we do is just add the exponent. Right, so since both bases are the same on the both sides of the equation, we can just compare the exponent. right, and bring all the x together on the left hand side and divide both sides by 3. Right, sometimes the questions are not so straightforward, meaning that there's no way that you can actually express the number given in the equations with the same base, and especially also um, when you have equations that you have 3 terms. So that means the case you have to use this very good method called the substitution method. Right. So if you look at what you're supposed to substitute, it says that you need to substitute 2 to the power of x with the letter u. So they give us a hint that I would need to express the number given in the equation as base 2 and to the power x. So 4, we can write it as 2 to the power of 2. And I'm going to convert the brackets into times the symbol for multiplication. Okay, here, right, we're going to apply this rule here. Okay, if you have 2 terms, then you have to remember to multiply m with both terms. Okay, so that will give us 2 to the power of 2x plus 2. Now I still cannot do any substitution yet because I have to break this guy up right into 2 to the power of x and something else. Right, so earlier on we say that the importance of able to work backwards. Right, what do I mean? If you're given a to the power m times a to the power n, this is working forwards. You'll get a to the power m plus n. But what happens if you're given a to the power of m plus n? You should be able also to break it up into a to the power m times a to the power n. That means from one base, you're able to break it up into 2 bases of the same kind. So this is applying in the forward manner, and this one is applying in the backwards manner. You must be able to do both. So therefore, this one will give us 2 to the power of 2x times 2 to the power of 2. Alright, we are not able to do substitution yet because we still have to apply one more rule here. This one can be written as, okay, you get the same answer. You get a to the power of mn. Therefore, for this, right, we can write it as this. 2 squared, you can simplify as 4. Alright, so now we can do our substitution. Okay, because we have finally simplified everything possible to 2 to the power of x. So now we can replace 2 to the power of x with the letter u. And what do we end up with? We actually end up with a quadratic equation. Okay, right. So with the quadratic equations, you can use the calculators to help you find the values of u, or you can use the quadratic formula. Right, you will have u equals to 1/4, or u equals to -2. Right, the calculator is just a means to help you to get the answer. Right, so if you need to put it back into fractals, then u equals to 1/4 is actually 4u minus 1. U equals to -2 is u plus 2. Okay, so from there, I will get u equals to, I have to apply the zero product rule. Zero product rule, that means 4u minus 1 equals to 0, or u plus 2 equals to 0. So that will end up getting u equals to 1/4, or u equals to -2. Right, but remember that u is a substituted values for 2 to the power of x. Right. Ultimately, you have to find the values for x. Right, so since u is a substituted value for 2 to the power of x, we will have to substitute our u back as 2 to the power of x. Okay, then 1/4 you can write it as 1 over 2 squared. And 1 over 2 squared you can write it as 2 to the power of -2. So from here, x is equal to -2. One answer. So the second answer would be 2 to the power of x equals to -2. Now, so this is impossible. Why impossible? Because on the left-hand side, you are having a positive answer, and on the right-hand side, it's a negative answer. Right? You can't have like +2 equals to -2. It's not possible. It does not make sense. Hence, for this, we will have to reject the equation. So you either say reject, or you can say that it is not applicable, because there's no values of x such that the left-hand side is a positive values and the right-hand side is a negative value. So the only answers that you can have here is x equals to -2. Let's try another example. Okay, so if you look at what you're asked to do, we need to substitute 3 to the power of x with the letter u. So let's look at the equation. All right, so they give us a hint that we have to rewrite 9 as 3 squared. Change the brackets to times. All right, multiply the power to get 2x plus 2. Break it up into 3 to the power of 2x times 3 to the power of 2. Okay, and then interchange, rewrite 3 to the power of 2x as 3 to the power of x bracket to the power of 2. And 3 squared is 9. All right, we are all ready to do the substitution now. So we replace 3 to the power of x with u. So you will have u squared times 9, so 9u squared. 1 minus 8u. Bring everything to the left-hand side, so you end up getting a quadratic equation. And if you use a calculator to help you find the values of u, you would have 9u minus 1u plus 1. So therefore, u is equals to 1 over 9, or u is equals to -1. All right, so u is the substituted values for 3 to the power x, so we have to put back our 3 to the power x. And 1 over 9 can be written as 1 over 3 squared. And 1 over 3 squared is actually 3 to the power -2. So therefore, x is equals to -2. And for the other one, okay, again, this should be rejected because it is not possible to find any values of x such that the left is a positive value and the right is a negative value. It's not possible at all. Learning how to simplify expressions involving indices, learning how to solve exponential equation where you express it with the same base and compare the exponent. And then just now we learned to use, in the earlier slide, sorry, not just now, in the earlier slide we learned to use the substitution method. Right, one possible type of questions is that you're given two equations and you're asked to solve simultaneously. Right, you're asked to solve for the unknowns x and y. Okay, so how do we go about doing it? So let's look at the first question. So if you look at the first equations, one likely possible method that we'll be using is to express all to base 3. So I'm going to change the bracket again to times. So 9 is 3 to the power of 2. 27 is 3 to the power of 3. Okay, multiply the power. Change 1 over 3 to the power of 3 as 3 to the power of negative 3. Okay, so now we have equations where you have the same base, so we can compare the exponent. Alright, so you will see that I managed to generate an equation involving x and y. I will make x the subject because later on I would substitute x into my second equation. Alright, so how do I get the second equation? Of course, from the second equation as given. So quite obviously, we need to express it as base 2. So 4 is 2 to the power of 2. And 8 is 2 to the power of 3. Okay, so simplify further. Alright, so this one here, I'm going to apply this rule, which is the same as, if you were to convert division to a horizontal line, it's the same as a to the power of m divided by a to the power of n, and that gives you a to the power of m minus n. So that gives me 2 to the power of 2x minus, make sure you bracket your y plus 1. It's very important. Let me repeat, to bracket your y plus 1. Okay, now we have the same base already on both sides. You can compare the exponent. Right, the reason why I say it's important to bracket it so that you will have to change the sign. Negative 1 times 1 gives you negative 1. Alright, so I'm going to substitute equation 1 into 2. So that will give me 2 bracket minus 3, negative 3 minus 2y, minus y equals to 4. Negative 6 minus 4y minus y equals to 4. Negative 5y equals to 10. So y will be 10 divided by negative 5, negative 2. Alright, so after finding y equals to negative 2, I need to substitute back into my equation 1 to find the values of x. So the values of x will be negative 3 minus 2 times negative 2. So that gives me negative 3 plus 4, that gives me 1.